And we're going live. And we're live. So, hello everyone, and welcome to another edition of Nomad Community Office Hours. And today we're going to be talking about the 1.2.4 releases. There was a previous message where we had said we'd also be going through the Learn guide, but Anthony's not going to be able to make it today as he's not feeling well. So Schmeichel is coming in to join us instead. And I guess just before we kick it off, I'm just going to do my quick reminder. As always, if you're joining us for community office hours, we do have community guidelines and a code of conduct. In general, we expect you to be welcoming, inclusive, friendly, and patient, be considerate, and be professional. And with that, I guess, Luiz, would you like to say hi?
Sure. Hi, everyone. My name is Luiz, and I'm engineer in the Nomad team.
How about Schmeichel?
Hi, I'm Michael Schurter, Schmeichel just about everywhere, and I'm the Nomad team lead.
Awesome. And yeah, I'm Jackie. I'm a developer advocate here at HashiCorp, and we'll just get started, I guess, with Nomad Community Office Hours. I wasn't actually really sure how I wanted to kick this one off, but I think we literally just released it like a couple hours ago, right?
Yeah, it was a long process, but yes, we are live with 1.2.4. It's a minor release, but there are lots of improvements that we made in terms of most the stability and being able to fine-tune the scheduler a bit more. So maybe I can start by going over the changelog a bit, just like
sure. Yeah, that sounds great.
Covering the highlights. Let's share the screen. Works. So this is the changelog. You can find it in your GitHub page, and that's the release we did today. Not a lot of, quite a lot of improvements going on here. The main ones are sort of like around the scheduler. They're pretty cool, but there are also some nice improvements around the, like CLI, just making it more user-friendly. Improvements on the API. We're now starting to add like pagination to some of our endpoints, which has been a long ask. And then some like nice UI improvements as well, just to make it more user-friendly and like help facilitate navigation. And also a lot of bug fixes went into this release. As I mentioned, like we're trying to target for stability and maturity of the release process. So a lot of the work went to like finding annoying bugs, especially down into the scheduler, which is like always the hardest part for us to improve. But we spent like a lot of work finding issues that happen not just a large scale, but like also smaller deployments can also trip in some of those. Anything you want to highlight, Michael, from the release?
I don't think so. Other than I mean, would love to dive into those scheduler changes, but I don't want to steal it from you since you did a lot of the work. So if that's what you were going to go into next, go for it.
Cool. Yeah, like I think it would be nice to, because a lot of the changes that we have, anything in scheduler is scheduling, like all of these are mostly tuning how the work gets scheduled inside Nomad. So I thought it would be interesting to just explain what this scheduler is, how it works, and why do you want to have those extra knobs and when to use them. So I'm actually going to try and make drawings again. Again, sorry for my handwriting, but I think this helps more. So a quick overview of like how the Nomad architecture works. We have two types of machines mostly, servers and clients. So normally you have like 3 servers, usually an odd number of servers, and they are responsible for storing state and establishing consensus. So they're often like communicating and like exchanging data to make sure that the view of the world stays the same between them. And then you have multiple clients that are actually running your workloads. So like your Docker containers, your jar files, all of that are running in the clients. And like this is where like your user traffic comes in. One of the servers gets elected as the leader. So let's say like this is the leader. And what this means is that the source of truth lives in this machine. If the leader goes down, the leadership gets switched between one of the other healthy ones. But normally, in normal conditions, you have a single leader that stores the source of truth that gets replicated across the other servers. Now, what happens is if you have like a job file describing a new workload that you need to run, that request will, find its way to eventually find its way to the leader. And what the leader would do is inside this leader machine, there is a queue of work. So what this queue does is synchronizes all of these requests. So imagine you have multiple users on Nomad trying to deploy things. The queue is a way for the server to like serialize all this process so you don't get to a weird race condition and things like that. And then the work that gets scheduled here are called evaluations. So all of this that gets into the queue are called evals for short, but they're called evaluations. And what the evaluation is a attempt to get the job and transform into actual allocations. So lots of names here, but basically the job is your blueprint, sort of like it's where you describe what you want to run. The allocation is what actually gets run. So like what actually gets executed on your clients. And then the evaluation is like the between step is like where the server kind of decides where things will run. Because the work of a scheduler is given a job, how do I find where to run things? So that's in a nutshell what the scheduler does. It's like it looks all the clients, their usage, and finds the best place to run things. So that's what the eval is. So the eval is an attempt to transform job into allocations. So this evals, when you do Nomad Run, you generate this evals into this queue. So this is normally a first in, first out sort of data structure where evals come in and like they are processed in order they come in. But the thing is, in order for us to scale better and like make use of all the extra, power that are in the other machines, the actual planning of these evals happen across all three servers. Even though the leader is the one that has the source of truth, the actual generating of these evals happen in a distributed manner. So when work gets enqueued here, all these other servers can go and dequeue this eval and like work on it. So dequeue, I think that's how it's spelled. Words are hard. But the eval can be dequeued and then it gets worked on. And the result of that is a plan. So the worker generates a plan and sends back to the leader. And then the plan is like, this is what needs to happen. And then the leader has another queue of plans that serializes all the plans and making sure that they are correct and they are actually feasible and like there's no conflicts between the plans, because remember, this all happens in a distributed way. So this worker or this server is also doing this dequeuing and generating plans and all of that. So the leader is also the synchronization point to serialize the changes to make sure that this plan here on the left doesn't conflict with the plan on the right. So for example, if this plan generates an allocation that requires a specific port, and this plan also requires the same port, you have a conflict that will be detected during this plan apply phase here. So that's normally the flow, how it works. Another detail is that inside each server, there are kind of different threads running inside the server. So these are called the workers. And so each server is actually processing these evals in parallel as well. So you have like, let's say 10 workers here, 10 workers here, and even 10 workers on the leader. So in theory, you could process like 30 evals in parallel at the same time. This is like for performance and like making sure that the work gets distributed. So that's the normal flow. Did I forget anything, Shimako? Did I say anything wrong?
No. This is a great description. And if you're feeling like the diagram might have gotten a little cluttered and messy, I think that's part of the accuracy of it too. Is it's there's a lot going on in this process. Maybe one quick like clarification, because I think a lot of people who either use Nomad or have read about it maybe a little bit, know that the Nomad servers talk Raft to each other. And so just kind of clarifying that those horizontal arrows between each of the servers, you could kind of think of as Raft. That's a consensus algorithm. When you submit a job, they all say, okay, here's a job. We're going to save that, to our local database. That all happens through this finite state machine. But then there's the eval processing and the dequeuing and the threads and workers, and that is all outside of Raft. And so, yeah, that's a really important distinction, I think, for people who even are somewhat familiar with Nomad.
Yeah, right. So like this dequeue, for example, happens over the network. So this is like an RPC request that happens from one server to the other. So, uses a different port and a different mechanism than the consensus from Raft here. So yeah, so ideally that's how things work. Doesn't always happen that way. So that's why, we improved on this release. So let's go over some of those. Let me pull the changelog again, trying to remember what those were. First one in the list is I want to talk about the priority. Forgot what the entry log is. Yeah, this one. So I mentioned that there is this queue where it's like first in, first out. So the evals, let me go back to declare drawing. I think I'm going to change color just to make it more clear that this is the new stuff. So this queue here is a first in, first out, but in reality, it's a priority queue. So all jobs have a priority value that you can set. I think it defaults to 50, like mid-level. It can go up to 100. I think it can be negative, or maybe.
No, I think it's awkwardly, no, it's 1 to 100.
Okay, cool. So it starts in the middle there. And this priority defines two things mainly. So one, it defines the queue order. So if you have priority 100, it will skip the line and be evaluated right away. And the other thing it does, it defines client placement priority. So if you have a job with priority 100 that must run on this node, it will remove this allocation because it needs that extra space. So this process is called preemption. So those are the two things that the priority sets. The unfortunate aspect is that sometimes you just want this, sometimes you just want this, and having a single value for both kind of confuses things. So for example, if your queue is like super large, but you must like stop a job, you need to be able to stop a specific job for some reason, and you need that request to stop the job to jump the queue. So, you can shed the load or something like that. If you change the job priority to do that, now you're like having to register the job again just so you can stop it. So you end up generating even more load when your goal is to reduce the load. So starting on 1 to 4, what this will allow you to do is define, I should open the docs for this, define a value for just that queue priority. I think it's in the CLI. And so, zoom in. So now there's a new flag called eval priority on job run, job stop, that you can pass in that will set the value for this. So you can have a priority 50 for preemption, but a priority 100 for evaluation. So let's say if you need to stop a job that is already running, you need that stop request to jump the queue. You can set that request priority to 100, and like that will go on faster. So yeah, so that's one of the changes that we made. Did I forget anything, Michael?
No, I think maybe to give an example of where this is useful in practice is, while Nomad, the entire reason for the design of this concurrent scheduler is for performance. So Nomad can schedule your work and get it running as quickly as possible. It's definitely possible for these evaluations to back up. Maybe it's a disaster recovery situation. The bunch of nodes are coming on the line, but a bunch of nodes went down and you're trying to reschedule a bunch of work. Or maybe it's just a batch job situation where you just kind of schedule a huge number of batch jobs to kind of get work done and just want Nomad to kind of get those scheduled and work through this backlog of evaluations as quickly as possible. In those situations, being able to skip to the front of the line can be really useful because you might want to kill that job, like Luiz said, to free up more capacity for the other things that are already in the queue. Or you might want to have a job that's just more important get running as quickly as possible. So this is hopefully one of those things to give operators really fine-grained control in moments where you really want more control, where maybe things aren't going well, or maybe it's just high load, or you just need to get Nomad working as quickly and efficiently as possible. Hopefully this will be a handy thing to reach for.
Yep. Cool. Yeah, so that's eval priority. There are new labels, there are new API fields that you can set this value to. I used 100 example, but I think in general, try to avoid 100 because 100 is the maximum. So slowly increase the priority there. But now you have that control. The other entry that I want to talk about is
maybe one more quick note about evaluations and the priority. How do you tell if you have a queue of evaluations that you even need to jump to the front of? And so we have some metrics available for that. I think if you go to Nomad Project.io and, oh yeah, you're there under, what is it, docs, operations, metrics reference? Yeah, so luckily under key metrics, we kind of list some. That total ready, Nomad, it repeats, sorry. Nomad is both the project and what we call the scheduler a lot. So when you see Nomad repeat, that usually means that it's the scheduler. Naming things is hard. And then that broker that it's referring to is the evaluation broker, that's the queue. And total ready is the number of evaluations just hanging out in the queue waiting to be processed. And so if you see that growing, that means that the schedulers just have a lot of pending work that they're trying to churn through, and skipping to the front of the line might be beneficial for emergencies.
Yeah, that's good. Like we also added, I think this is fairly new section from the docs of like which metrics you should be looking out for. So those are the important ones to plot and like monitor your dashboards. The other item that we have
Before we
is,
move
yeah,
on, I'm going to interject very quickly. Sorry, Luis.
no, go for it.
Just wanted to do a reminder for anyone watching that we are taking Q&A as well. So if you have any questions, please pop them into the YouTube chat. And on that note, we did get a question while you were talking earlier, explaining. And the question was wondering if, I'm just going to read it instead of trying to paraphrase as I'm reading. It says, speaking of Raft and RPC and Federation, is there any possibility of using Nomad over Console Connect mesh gateways or getting the Nomad API in Console Connect for job forwarding?
So to access the Nomad API through Console Connect, is that the question?
Using Nomad over Console Connect mesh gateways or getting the Nomad API in Console Connect for job forwarding. So I think so.
Yeah, like I haven't tried it before. I kind of want to say yes, just because it's like HTTP requests all the way down, but I don't think it'll be that transparent. I think, yeah, this is a good question. I think you might need to run a sidecar on the host to do that, like to add Nomad to the mesh. Maybe with a gateway, either a terminating gateway or ingress gateway might allow you to add that traffic into your mesh. But I haven't actually done that myself.
Yeah, same. This is yeah, that's a really good question. And it's yeah, too bad that Nomad can't natively take advantage of Console Connect service meshes, especially for things like Federation, in which you often have to communicate between Nomad clusters over the internet. You know, it'd be really nice if that could just use the wonderful security features of Connect or something like that. But right now, today, it would definitely be a very manual process of getting the gateways configured. Yeah, everywhere you need them.
Yeah, and I just want to throw out too, this is a pretty good question. Behind the scenes, we've also got a pretty spirited discussion going on about what that would look like and how to implement it. That's not currently on our live stream, but yeah, that's started a lot of conversation. So yeah, just, if you've got questions, drop them into the chat and we'll get to those, and I will let you continue on now. Sorry about that, Luis.
Oh, no problem. Feel free to jump in anytime. The other item that I was going to mention is the no shutdown delay that we added to job stop and Alex stop. This is similar to that situation where like you need to stop stuff to shed load or to like improve some performance. So the way this works is that normally, let me remove these old drawings. Normally on the job, you can also set I think it's called shutdown delay or delay shutdown. I don't remember the order, but I think it's shutdown delay, which if you have like an application that needs to drain connections or like do some extra work during shutdown, you can ask Nomad to wait. So, because like by default, when you stop a job, Nomad will right away stop your allocation. So it's going to stop your container right away. If your application needs that extra time to shut down, you can add or increase that delay. So Nomad waits a little bit more to actually stop the allocation. But in some situations where you have, I don't know, like your cluster is fully loaded and you need to stop jobs right away, even though you have this configuration, before you wouldn't be able to do that because again, you need to change the job, re-register the job, which generates more load, which is counterproductive to what you're trying to do. So if there's new option, you can do a Nomad stop. Should you change the color? You can do a Nomad stop with, I forgot what it's called, with the new value, no shutdown delay. then we'll just ignore the shutdown delay and stop things right away. So that will help you, like, because sometimes some applications take a while to stop, and then you set a high value for this, and then you get into that corner where, like, I need to stop this right now. So this flag gives you that that option to just stop allocations and clear the load on your cluster. And I think I should check the docs, but I'm pretty sure this is for the job and also specific allocations. Yeah, so job stop and alloc stop have this new flag. You pass in, they will be shut down right away. So again, pretty useful tool to have when you're like in a bad place and you need that extra help.
Yeah, because just to elaborate a little bit, that shutdown delay is handy for when you have, in-flight work maybe in a service that you want to give that time to finish before it shuts down. So you want to remove the service advertisement from console, wait this shutdown delay for any in-flight work to kind of finish up, and then, actually stop the process. And so to have a way to short circuit that is super handy for emergencies where, maybe there's something more important than the in-flight work going on, and you just need that thing to shut down as quickly as possible. Or maybe there's a system-wide outage and there is no in-flight work to even worry about. So at that point, shutdown delay is just getting in your way and slowing down whatever you're trying to do to get your cluster back to a healthy state. So one of those things, hopefully, you never need, but will be super handy if you do ever need it.
Yeah, and just to go a little bit deeper on what the allocation stop process looks like, and correct me if I'm wrong on anything, Michael, but normally when you stop a job or stop an allocation, Nomad will send two signals. So the first one, it will send a sig int first. So that's like a graceful shutdown. It's like you're going to stop. So this gives you time to do any extra work and like, drain connections, whatever, write to disk, whatever you need to do. But then after a while, and I think that's what the shutdown delay is. No,
that's kill timeout.
That's kill timeout.
We have kind of two flags to help tweak this. So kill timeout is the time between the nice friendly you can ignore it signal to shut down and the actual kill, you can't ignore this, the operating system is going to remove your process immediately signal. So you can get around a long kill timeout using the alloc signal existing API and CLI by just sending a sig kill or whatever the equivalent is on Windows. I forget, but yeah, the Windows support should be there too.
And the shutdown delay is the sig int delay, or
the shutdown delay is from when we remove the task from console. So it is specific to, it's to prevent new work from coming in. So, say it's some sort of web server, an API server of some kind. You tell it to stop. Nomad will immediately remove it from console. It will then wait the shutdown delay. Let's say the shutdown delay is 10 seconds. So it just waits 10 seconds. Then it sends sig int. Then the kill timeout timer starts. And if your process still, and say that's 10 more seconds. So after 10 seconds, if your process hasn't shut itself down, then Nomad will send the sig kill to shut it down forcefully. Or within those, this would be a great thing for a diagram, wouldn't it? I need your fancy drawing sketchpad thing, because yeah, it's the shutdown delay is the time between the console deregistration and the initial signal, and the kill timeout is the timeout or the duration between the first signal and the forced stop.
Nice, cool. Yeah, see, I'm learning stuff as well.
I feel like that's one of my favorite parts about these. Like, I always come out of it just like, oh, I've learned something new today, and that's awesome.
Yeah, it's pretty nice. So yeah, so the new flag affects this part here, so the shutdown delay. And you could already, before you could already change the queue timeout, but we added this control for this part here. Yes, and the next thing is, I think they're bug. No, they are APIs to control the scheduler. So this one, for example, is another feature that you would use in those bad situations where like cluster's overloaded. Like I need my servers to stop doing work, basically. So this is a new API update. I should show on the docs that adds new options to the scheduler. I think it's here. Yes, so this new field here on the operator scheduler configuration post request allows you to change if your servers will accept more work or not. So when you set this flag to true, all job registrations will fail. So you're basically like putting your servers in like maintenance mode, like no extra work can be added to the cluster. Again, this is for like those situations where you need that, like, no, I need to like fix my cluster before I can accept more work. But this new API is very handy for that. And you can set them on the fly. So since it's an API request, you can turn off and then turn on later after your cluster is in a better place.
This is,
yeah.
Oh, sorry.
No, go ahead.
This is hopefully really useful for people who have automated processes that run jobs. So whether it's like a CI/CD system that automatically builds and deploys on Git commits or things like that, or whether it's maybe some sort of like a batch processing, machine learning training. So whatever sort of work dispatching program you have written that might make job registrations to run work, and those might make more job registrations to do even more work, and really uses Nomad as a work runner. In both of those situations, if you run into a situation where you want to do maintenance on your cluster, like Luiz was saying, there's not a human to go tell, hey, could you just hold off for a minute, not schedule work? I'm trying to like look into something. There's all kinds of services and robots and things doing stuff. And maybe the operator who wants to quick peek at something in Nomad doesn't even know everything that might be submitting to Nomad at the time. And maybe it's 3 a.m. and they don't want to wake people up to go ask them, hey, can you shut your system down so I can do some poking around? So this is hopefully a way that somebody could just quick hit a pause button on new work happening. It won't pause the scheduler. So say if you have a node go down, Nomad notices that happening after heartbeat grace and some other configurable timeouts, and will reschedule that work. And that sort of stuff will still work. This flag is purely just so that no new job registrations coming in they're all rejected. So an operator can kind of poke around without interrupting Nomad's normal work, but still prevent new work from coming in.
Right. Yeah, that's also super helpful. And I think this is only exposed through the API. So you're going to need to make like API requests to set this flag on and off when needed. The next item is also an API change. Right, the next one. So this API, I think, is also on the same. No, it was servers, I think. I should read the changelog more. No. Nodes is nodes.
What are you looking for? I was
Enum
distracted.
scheduler API.
Yeah.
Look at the.
Poor Charlie who implemented that is probably.
Because I
tearing his hair out.
remember it was somewhere, and then I thought maybe it goes somewhere else. But I forgot. Let me find. Oh, agent, yes. So on the agent endpoint, there is a read and update scheduler worker configuration. So what this would do is that it allows you to change number of schedulers and the schedulers that are enabled, disable on the fly through an API request. So looking back at the drawing here, I mentioned that each server has a worker threads running and like doing this planning, scheduling, like this whole process behind the scenes. There are a number of threads doing that. That up until now, it was hard-coded to, I want to say 10, but I think it's based on CPU cores. I think it's half cores or something like that.
I think it's num cores, except on the leader, we cut it down to like half or a quarter. I forget.
Yeah, I remember there is a division somewhere, but it's proportional to the number of cores in your machine. If you have a lot of cores, or in some situations where you kind of want to slow things down a little just to avoid parallel work, like potential race conditions, or just like you need to like calm down the servers a little bit more, you can use this API to change the number of workers on individual machines. So that will give you kind of a more serialized view of your servers. When things run in parallel, they're often harder to debug. So being able to control the workers on the fly gives it that like ability to perhaps understand better what the problem is and just like rule out other situations like that. So yeah, so that's also a very nice API endpoint when you're in those bad situations.
Yeah, and the Nomad plan apply, or nope, sorry, Nomad plan queue depth metric. Do you mind, Luiz, hopping back to that metrics reference page and look for queue_depth? This is a great metric to watch to know whether or not you should tweak the number of schedulers you have. What this metric is, yes, perfect, thank you. That's a great one to watch to know whether your plan applier is kind of keeping up with the amount of scheduling work going on. So what I mean by that is, remember you have that eval queue, workers pull things to be scheduled off of that queue. Yep, perfect. And there's lots of those workers, num schedulers times number of servers, number of workers, all making these plans for how to schedule these jobs. They'll submit those plans, if you remember from Luiz back toward the beginning, they'll submit those plans back to the leader so that the leader can serialize and do a consistency check against them. Since they're all making it in parallel, they might be making conflicting decisions, right? They might try to all schedule onto the same node or all try to use the same port on a single node. And so it's the plan applier's job to serialize checking these one by one, which is a way cheaper job than the schedulers have. And that's why we do that concurrently. But if you see that plan queue depth metric ticking up, that's a pretty good indication that you have way more schedulers doing work than the plan applier can process. And the pathological situation here is that that increases the likelihood that there'll be a conflict. Because if you have 100 plans in this queue, by the time you process, say, the first 50, it's way more likely that those last 50 that are in the queue, they were created against an old view of the cluster, right? They were created against a view of the cluster that didn't take those first 50 into account. And so now a whole bunch of cluster resources have been taken up in the meantime. The likelihood for some sort of conflict or resource starvation to occur is way higher for those last 50. And that just means the plan applier will fail its checks, tell the workers to redo that work. And so now all of our concurrent scheduling to try to speed things up is actually causing things to do a lot more work than they would need to do. Not necessarily slow it down, but still just kind of wasting CPU cycles, just doing work that's going to get thrown away. And so having num schedulers is in an API where you can kind of tweak and see and look at these metrics like queue depth or plan queue depth, as well as look at that no eval ready gauge as well. You know, you can kind of balance how quickly you're churning through evals versus that planned queue depth. This is hopefully something, you know, the majority of clusters never need to worry about. But for the people who really, you know, have large clusters, want to get the most performance, the lowest latency, all those fun things out of Nomad clusters, this should give you a lot of really good tunables to be able to quickly and easily play with to fine tune things, as well as like what Luiz was saying. You know, it's another part of our pause button theme for this release, where we just keep seeing people have clusters that are in a state. Maybe it's a good state, maybe it's a bad state. They just, for whatever reason, like need to pause it a little bit to inspect things, ensure it's doing the work they intended to do. You know, really quickly dropping all these num schedulers to like 1 would be a great way to kind of really slow down the system, make it a lot easier to see what's going through it, and give yourself some breathing room.
Yeah, more knobs to play when you need them. Hopefully you don't, but if you do, they're there. I think those are the improvements. They're bug fixes. They're always fun to talk about.
We do have a couple more questions if you'd like to take a pause. It's always so hard to transition in, because I'm like, I don't want to interrupt you. I'm just going to gently kind of float in and be like, I'm asking questions.
Yeah, I'll go.
Anyway, thanks. So the first one we had come in was, I think Schmeichel said he could talk for an hour about this one. So he already has regret. Oh yeah, you can't see him, but he's covering his face. But, can we get rolling upgrade semantics for template changes as well, like stagger? Currently, when template changes, all instances go for the relaunch, and splay is the only thing we have to fiddle with.
The short answer is no. The longer answer is yes, we would love to do that someday. So I think kind of the crux of this question we've had, I think, since probably before we had deployments, but basically right now, today, and since we first introduced the template stanza, the only tunable you have to control how quickly changes in console or changes in vaults are cause your service to actually get restarted or sig hupped or whatever when the template is rewritten is display configuration variable. And it is just a number like 5 seconds, 5 minutes that we randomize on each allocation. So say you have 10 API servers, they all pull some config from console using console template. Somebody updates that config in console. They all get their templates rewritten, and then they all wait some period of time in that splay before they're restarted. So how long should they wait? Should that splay be 10 seconds so that they get restarted pretty quickly? That might be safe since you have 10 API servers. It might not be. Should it be 3 seconds? Well, now you might be taking down too many API servers at the same time. What if they take 10 seconds apiece to restart? Then you could cause an outage every time you update console. It's a really tricky situation, and splay is just not a powerful enough parameter to really give operators the fine-grained control they need over this. So deployments, this is what deployments are for, right? Deployments have all of the features involved to make sure that you can do a deployment without taking down your cluster. There's canaries, so you can deploy just one or just three of a new job at a time and wait for it to be confirmed healthy before updating everybody else. You can control how many allocations you roll out at a time and kind of the rate that it happens at. You can control the health checks that are used to make sure that the allocations are healthy before you continue with a deployment. Like, deployments have all kind of the knobs that you would want for rolling out configuration changes from console. But sadly, deployments only happen when you do a full job update, whereas the nice feature of templates is they're just monitoring console for configuration changes before you in the background. There's really no easy way in Nomad to just kind of copy and paste all of those deployment features into the template stanza, because the template stanza is purely used by clients, by the actual node that is running your workload. It sees, oh, splay is 10 seconds. Great. I'll pick a random time between 0 and 10 to do this in. And so there's no coordination. So if you're running those 10 servers, they all pick their own time display. There's no coordination. None of them tell the other ones, okay, I'm healthy, it's your turn now. And so it would really take a lot of new plumbing and new work to kind of port that to the template stanza. Not saying we won't do it. It'd be a great thing to have. It's definitely a hugely sought after feature, but it is a lot of new plumbing that we don't have today. So I think if you really need it, the best solution today is to probably use console template, the tool, the program, to submit jobs. And so you could even run console template as a Nomad job, and it can watch console for updates to whatever key you use to control configuration for a job. And then it can submit job updates to cause a deployment when those things in console changes. Obviously, that's pushing a lot of work onto users that we would love to do for you. But if you want deployment semantics for console template changes today, I think that's really the only way you can get them. Look at that. That was way under an hour. That was very...
I'm so proud. I'm so proud. We had another question come in too. Well, there was a follow-up to that one that I think you might have answered actually at the end. The follow-up to that one is using template from console frowned upon compared to deployments?
Yeah, I mean, the deployment behavior is what people want. So it's kind of the only solution today then is, changing your workflow to take advantage of that, which stinks. We shouldn't ask you to do that, but that's what we have today. And hopefully our template stanza can be smarter in the future.
Perfect. And then scrolling. The other one says, quick question, is there an Are You Leader API which returns success only on the leader server? Or leader-specific console tags with the use case to send traffic via reverse proxy only to the leader?
To answer the second part first, because it's easier. Luiz, I don't know if you want to be searching for the answer to the first part while I delay for time. The use case is to send traffic via reverse proxy only to the leader. The good news here is that by default, that is what Nomad will do for you. So Nomad has the HTTP API. That's what our CLI tool talks to. That's what the UI talks to. That's what any programs that you write to instrument Nomad talk to. But that HTTP API is actually translated to an RPC behind the scenes, an internal RPC protocol. If you've had to configure the ports for Nomad or control, firewall settings and things like that for Nomad, you've probably seen that RPC port in play. On the servers, RPCs by default are always forwarded to the leader. So just because your HTTP layer can talk to any Nomad agent, it can talk to any client agent, it can talk to any server agent. For most APIs, those will get forwarded to the leader by default. There's some exceptions there. There's client APIs that are made to talk to a specific client. There are some agent APIs. Agent APIs are almost always designed to talk to a specific agent, whether it's a client or a server, like that num schedulers API we were talking about. That's whatever server you send that num schedulers request to is the server it will be applied to. But for almost all other APIs, so like job submission, listing jobs, those are all going to get forwarded to the leader and then responded all the way back to you. So you shouldn't need to set up a reverse proxy just to talk to the leader. In fact, I would highly recommend whenever calling an API that supports the stale flag, which almost all read APIs do, use that stale equals true. It should, I think the fact that it's named stale scares people, but it should, because of the way Raft works, it should always provide you, it will always provide you a consistent answer. It might not be the freshest, but that's usually on the order of, milliseconds or seconds. Anything beyond that, and you're going to have, Raft consensus issues anyway.
And to answer the first part, yes, there is status leader. Thanks, Tim. I remember there is the agent self endpoint, but you need to actually query each one. So yes, there is the status leader that gives you the leader for that region.
So if you're worried about performance of your servers and using as little CPU as possible, which might be a reason that you're looking to, talk directly to a leader, so you don't have to go through the forwarding, that's fine, especially for APIs where you don't want to use stale. For instance, any write API is going to go to the leader. The leader handles writes, so job submission is going to go to the leader. So that'd be a great thing to just send to the leader anyway. No proxying happening behind the scenes. For anything else, the stale flag is great. And in fact, the stale flag and making sure you're not talking to the leader, because the leader already is doing more work than the other servers are. That being said, if the proxying of requests is ever a big performance concern, yeah, I'd be a little worried. There's some cases where I could see that being true, but for the most part, that proxying should be one of the cheaper things Nomad does.
So I do see that we're coming up close to time. I guess we have a couple options. We can start wrapping up, or if you'd like to go a little bit longer to go through the bug fixes, we can go a bit longer pending your availability, basically.
I'm afraid to continue.
Yeah, I'm good for a little bit longer.
Sure, okay.
Cool. So I was going to mention there are some bug fixes that might be worth pointing out. So one of them was about there was a memory leak that was happening in some of the clients that might cause your clients to have a lot of memory usage, even though you may not have that much load in them. So that's something to look out for if you're having that excessive memory usage on your clients. And for the other thing that I was going to point out during the template discussions that we do added a few extra tunables to the template stanza. Not exactly what we're talking about, but it gives you a way to not redo work or like fail if like console is down or console or vault goes temporarily down, for example. It gives you more control of what Nomad will do in these situations where console or vault are not available, because that traditionally could lead you to a sad time. Now it's configurable. And then the other bug fix it's going to talk about is in the scheduler specifically. That was happening.
The spread.
This one, I actually not sure if this one. I was looking for the plan apply bug that like I fixed it, but I don't remember what I put in the changelog. Probably the wrong key. But basically, there was a problem, or we started to notice a issue where this flow, a server generates a plan, sends to the leader for apply, and then a conflict happens in a very weird scenarios, like a port conflict, even though you're not using network for that specific jobs. Like this sort of weird situations were happening very sporadically, but like it would cause your work not to process. So it's a very bad situation. So we added extra logging on those scenarios. So if you do updates, if you're like seeing that kind of problem and you do update, and then you see like this huge message on your log, that's like the extra logging that we added to understand why that situation was happening in the first place. So if you do see those weird log messages, let us know so you can take a look at what's going on, because it's a very weird bug that we haven't been able to find the exact root cause. We deploy some mitigations on this release, but the actual root cause is still to be determined.
Yeah, and to elaborate a little further on that, I think thanks to this great diagram and you going through this, hopefully people can kind of understand how this problem can happen. And it's because where those evaluations get dequeued by these workers, and these workers come up with a plan, right? They look for nodes with the free resources to schedule the work on, they make a plan and they submit that to the plan applier, and the plan applier validates it. So right there, these two systems are both having to validate whether work can run on a node. If they have any discrepancies in their validation logic, if the scheduler thinks it can put a piece of work on a node, but the plan applier says, no, you can't, it doesn't fit. We get into this really insidious problem within the scheduler in which the plan applier or the workers might keep making the same plan and the plan applier will just keep rejecting it. And so we've actually seen some cases where, that kind of just causes this infinite loop where a job can't be fully scheduled because the workers and the plan applier don't agree. That is always a bug. And so the work that Luiz did and was just describing will give us a really great tool for helping to identify and diagnose this bug. Yeah, and there's great links from the changelog issue or from the changelog PR to the kind of root issue where there's a lot of good discussion about this can happen, how this can happen. Effectively, it's just a class of bugs that can happen. Thank you to, I should have had your name ready. A user submitted like a super easy reproduction for this, where effectively you could have a invalid reserved ports on your client, just reserve a port like 9 trillion, and that's not a valid port number. Nomad, the client, would happily start up, tell the servers, hey, I can't schedule on port 9 trillion, just so you know. The scheduler on the servers would go looking at nodes, and if you wanted to schedule work on that node, it would be like, oh, hey, there's no port conflict here. That's fine. That's great. I can schedule work on it. The plan applier would get that plan, would look at this node and be like, what is this port 9 trillion reservation? That doesn't make any sense. I can't schedule anything on this. And it would reject it. The scheduler would again make the same decision again. The plan applier would again reject it, and you'd get into that infinite loop situation. Even if your job didn't use networks at all, was what made this like really insidious to try to debug. Is it didn't even matter if your job cared about networks. The plan applier would reject things just because that node had an invalid configuration. Oh yeah, right there, bad Alex. Thank you, bad Alex. So that was a super easy case to reproduce. We now have validation in the agent to make sure that it doesn't happen anymore. You'll have to fix that reserved ports to be valid before the agent will start, because we do not want agents to be running in a state that Nomad doesn't understand. Like there's just no way we can guarantee correct behavior. So we crash early with a really nice error message for you. Hopefully it's a quick and easy fix, and you're back up and running. And so this is going to be a journey. This is not a destination, but thanks to Luiz's work, it should be a lot easier to diagnose and find, the other places that we're missing validation, and so bad data can get into the system, or other subtle bugs between how schedulers and the plan applier make decisions come up.
Yeah, in theory, they should do the same thing, but sometimes they don't.
And I know you're all thinking, well, why don't they just use the same code? And they do. We really try to get them to use the same code as much as possible. But there's always going to be some differences, because the scheduler just has to do more work than the plan applier does, because it has to search through lots of nodes, whereas the plan applier is just validating a specific plan against a specific node.
I think you broke Jacquie.
They can't see me because I'm not talking, but I've been laughing so hard my face just went red from that. I don't know why. I was expecting you to say anything else other than they do.
They do. We try. Believe me, I would love it if it was super easy to just use the exact same code in both places. Yeah.
So yeah, look out for this ugly log message if you see them. There's no in this issue here. I think one last thing, we're at time, but just to close, I wanted to also mention the UI improvements. There have been some very nice work on the UI. I could just show instead of showing text messages. So the first thing is a new configuration block that you can set on your agents that allows you to enable, disable the UI, or set custom URLs for console and vault. When you do this, it will give you a header link here for both console and vault, where you can click and go to console, and just easier to jump around between tools on their Hashi stack. The other improvement is just making our navigation more just easier to follow. So now we have labels on that breadcrumbs, because specific on the job, you can go really deep into the breadcrumbs, and then depending on how you name things, it's hard to understand what is what. So now we have labels there. And we also have a nice allocation clicky filter thing. Before, this was mostly non-interactive. So now you can easily click and jump to see which actual allocations are in that state. I think those are the main changes on the UI. And there will be more to come for 1.3.
All I want to say about the UI is, if you have not used it and you're a Nomad user, please go use it. If you haven't used it and you're not a Nomad user, please download it, spin up a dev agent, and just open up the UI. It just makes me more productive, makes all the users I work with are just so much more productive, and you can get around and see so much information so quickly and easily. And hopefully, people are kind of reading between the lines of the new UI config block and the new links to console and vault. This is just the beginning for kind of that functionality integrating the Nomad UI with our other products here at HashiCorp. we're not going to be duplicating their entire UIs within Nomad's UI. That's not the goal at all. But we absolutely want to get people to the information they care about faster. And sometimes that information is going to be in Vault, and sometimes it's going to be in console. And so hopefully we can deepen this integration to get you where you need to go as quickly as possible.
Yeah, and I think that's all I had to mention about the changelog. There's many more items, so go check it out and let us know if you find any issues or bugs.
Can I do one more, or we just wait? But is YouTube gonna like cut us off? I don't know. For Luiz,
We're good. You can do one more.
All right. Because I was talking about stale so much before, I wanted to point about yeah, it's right on this page. Fixed a bug where the stale flag was not respected by Nomad operator debug. I think this is a really interesting little bug for a few reasons. One is because, much like the UI, if you haven't used Nomad operator debug before, I mean, probably great, because that means everything's probably just working for you. But if anything is ever not working for you, if you're making a bug report, or if you're lucky enough to work with the HashiCorp Nomad support team, the first thing that our support team is probably always going to ask you is for a Nomad operator bug bundle. For open source users, we have an email address set up so you can send us engineers debug bundles, because you don't want to post them publicly on the internet. But operator debug bundles are great for having to debug bugs, issues, performance issues, strange behavior, whatever. It just collects a lot of information about your cluster and lets us debug it quickly and easily. A really interesting thing, though, that we had gotten wrong is that the stale flag wasn't implemented. And so that meant what I was talking about earlier, where every HTTP command, and the Nomad operator debug command makes lots of HTTP calls behind the scenes to gather all the information it needs. All of them were getting routed to the leader server. And normally that's great. That's fine. It's, you know, all the servers should have the same view of the world. They shouldn't return, you know, different information. Who cares, you know, that we weren't honoring that flag? It's annoying, but the leader was doing extra work. But functionally, it should be correct. Except, you know, the issues that we were trying to debug were cases where the plan applier, which runs on the leader, was making different decisions than workers, which could be running on followers. And so being able to collect each individual server's view of the world is completely necessary when you're wanting to find bugs in which they might have differing views of the world. So we can finally do that. Nomad operator debug will now properly get each follower's views of the world, and not just only the leader's view. And that will hopefully never matter, because we'll never have bugs again. But in the cases where we have a bug that causes the servers to drift in their view of the world, we'll be able to spot it. And so that's really exciting for us on the developer team, I think. That's it. That's it for me.
I think that pretty much brings us to a close then. So I guess first off, I'm going to thank both of you for coming on today. It's been really nice having you. Oh no, now I'm getting sad because now I know what I'm going to say. But yeah, so for everyone who's here and who's joined over the last 2 years, I just wanted to take a moment to say thank you. This is my last community office hours, and I've been happy to have both of you join me, and it's been great working with the community and having everyone kind of participate. I just wanted to take a moment to say I'm so proud of how the community and the team has grown. You guys have done awesome stuff, and you're going to continue to do awesome things. So yeah, thank you for joining us today. And with that said, we don't currently have any more community office hours like HashiCorp, not just Nomad, but nobody has any scheduled at this moment. But when you're interested in kind of seeing them come on, you can find them at hashicorp.com/community office hours, I think. I just linked it in chat. So feel free to check there to find a schedule for what's coming up. And yeah, thank you so much again, Luiz and Schmeichel. Is there anything you wanted to say as kind of like parting words for office hours? Well, not like it's not going away forever. I literally just mean for this episode. It's just I won't be here. That sounded so much more dramatic than I meant it to be.
I want to say thank you, Jackie. Thank you for for all of you watching. She does so much hurting of us poor engineers who are just like showing up late and being like, so what are we doing today? What's going on? Especially, I never know what's going on. So thank you, Jackie, for being so patient with me, for making these happen, for engaging so great with our community. You're gonna be missed. Yeah, this has been great.
Yeah, thank you. And like all the work you've done as well for like demos and presentations, not just here in the office hours, but like all your technical work as well has been super valuable to the team and the community at large. So thank you very much for that.
I didn't mean me. I meant the episode, but thank you.
You're not getting away easy.
Oh no. I've been like avoiding saying bye to anybody, so this is actually the first bye I've said. So been like running away out of meetings. Like, no, see you tomorrow. It's okay. But yeah. So yeah, just again, thank you so much everyone for joining. And there will still be office hours. Somebody else will be here, and the team's going to continue to do a great job. Working with these ones has been such a treat and a pleasure because you guys and the rest of the team and everybody else just always there's always these really fun situations and fun things we get to work through. We get so many different use cases, and the community is just so vibrant and enthusiastic, and it's really been such a joy. But yeah, I'll stop now. I could do a whole hour of thank yous, so to steal Schmeichel's phrasings. But yeah, that's all I've got. So I think if there's nothing else that we wanted to share, I'm probably gonna close it off and stop streaming. Yeah, all right. Thanks everyone, and have a good week. And yeah, see ya.